Let us recall our discussion about the three terms, which are algorithm, pseudocode, and program. These three terms are similarly defined as a set of ordered instructions to accomplish or perform a task or solve a problem. For the difference, for algorithm, this is written in human or English language. For pseudocode, it is written in both human and programming language. While for program, it is written in a programming language which can be compiled or translated using the programming language compiler or interpreter until the true executable code written in machine or binary language is generated, and then the computer executes the machine code equivalent of the original source code or program. So I hope the difference of these three terms are already clear to you. Again, this is the similar definition of the three terms, and this is the difference unique to algorithm. These are their differences. For algorithm, it's this. For pseudocode, it's this. And for program, it is this. So similarity, and then the differences are this one for algorithm, for pseudocode, and this one for program. This time, we're going to discuss about flowchart. What is a flowchart? A flowchart is just like algorithm. It describes a process on how to accomplish or perform a task or solve a problem. But flowchart is in graphical form. A flowchart is defined here as a diagram representing the logical sequence or a process in which a combination of steps or operations is to be performed. It is the blueprint of a program, just like algorithm and pseudocode are the blueprints also of a program. Another definition says that flowchart is a two-dimensional representation of an algorithm. The predefined graphic symbols of a flowchart are used to indicate the various operations and the flow of control. The flowchart graphic symbols are the following. First, we have this as the start or the end symbol. So we call this the start or end symbol, or we call this the terminal symbol. And the shape is oblong. And this is used to signify the beginning and the end of the flowchart. So for the beginning, there is a label start, and for the end, there is a label end. Every time you start a flowchart, you always start with that symbol, and when you end the flowchart, you always have this symbol. The next is the preparation or initialization. The shape is hexagon. It signifies the preparation of data. Okay, so you're going to initialize here. Like for example, you would say start, and then the next is initialization. Maybe you would say here x is equal to 0, y equal to 0, and z equal to 0. Say if your flowchart is making use of three variables, like the previous problem that we have discussed as an example, the getting the sum of two integers, where the two integers are x and y, and z is the sum. So that problem makes use of three variables, x, y, and z. And if we're going to create or construct a flowchart to describe the solution or the process to solve that problem, then after we start, we initialize the three variables using the initialization or preparation symbol, the hexagon. And this is used to select initial conditions, okay, and used to represent instructions or group of instructions that will alter or modify a program's course of action. The next symbol is called on-page connector. This is a connector symbol and the shape is circle with a label so that we could connect the disjoint flowcharts. For example, if we are on this page and we happen to have no more space here, so we want to continue on the top right side, then we're going to put in here the on-page connector and say we label A, and then we go up here and have this on-page connector here, and then we continue after the initialization is what's next. So this is an on-page connector. It shows the entry or exit point of a flowchart. So on this side, it is the exit point of the on-page connector, while on the top right is called entry point. This one here is exit point, and here it is an entry point. So it shows the entry or exit point of a flowchart subsection. This conserves space by keeping related blocks near each other, reduces the number of flow lines in a complex programs, and eliminates cross lines. If you are not using on-page connector, most likely you would do it like this, then continue. This is not a good practice. We call this a cross line, and it doesn't look nice to the eyes, and it makes the flow chart complex. It reduces the number of flow lines. So to avoid this from happening, we need to use an on-page connector. The next flowchart symbol we have here is called input or output symbol, and the shape is a parallelogram. And you write in here the instructions. This is for both input and output. So for example, the one we have a while ago, so you have here a start, and then maybe you have some initialization where you initialize the variables x to 0 and y to 0 and z to 0. Then after that, you input the first integer x. Again, this is the problem to get the sum of two integers x and y. So we draw here a parallelogram, and then we say input or enter first integer x. We could write it that way, or you could say enter integer x, whatever you prefer. As long as the instruction is clear, it is precise, specific. And then the next would be to input the second integer. We have this input the second integer. So maybe just like that, we would say input second integer y. And next is, say for example, we use a connector A, and then we continue here. We have here a process to get the sum of x and y and assign it to z. And then after that, we have to output the value of z. So since it is output, we use parallelogram again. So we would say here, output or display integer z. After the output is our end, right? So we have here the end of our flowchart. Now, this one here, the diamond shape is decision. It is asking a question like, is number x greater than 0? The answer to this question is only 2, right? Yes or no, or it is true, false. This has one input flow line and two output flow lines. So maybe you would say here, this is the way to go when it is true, and this is the way to go when answer is false. Or you could use the label yes, and you could use the label no. So if this question is yes or true, you would go this way. And if this question is false or no, then you would go this way. So again, it has one input flow line and two output flow lines. And the next is, as I have mentioned already, called flow lines. These are arrows, and these are connecting the symbols or the shapes. And this tells what is next to do, or tells the flow of actions. Like, for example, this flow line here, the direction is going down from this to that. It tells the direction of where to go next in the process. So from this, you go here, and then from here, you go to this, and from here, you go to this, and so on until you reach the end, which is this part. And always remember that it has a head. The head tells the direction of the flow, from where and going to where. The next symbol is a comment. Okay, this is a comment section, and you simply write here something to describe about the process or about the step it is currently in. So describes the process or action in details. Like for example, we would like to add a comment here. User inputs an integer and assign and store the value in X. So this is describing what is being done in this step. We call this again a comment. The next symbols process. It is a rectangle or a square. It is this one, a rectangle, or this one, a square. What we have here as labels are verbs or describing an operation. Like for example, add 1 to number X, or you say compute the sum. So these are verbs or actions, okay? Like add or compute or get the sum or subtract. Okay, so those are verbs, and it describes an action or a process. So like the example we have last time, that is adding two integers x and y. We start with this symbol, the beginning marker, and then a flow line directing to initialize the variables that are used in this flowchart. We set those variables to 0 as initial values. Now we set them to integer 0 because we intend these variables to hold integer values. So instead of writing it this way, which means that x is not an integer variable but a real number value. So this would be integer. And after the initialization, we input the first integer. And then next is we have no more space here, so maybe we could use an on-page connector. Then we continue here. Take note, this is on-page connector. If you go on another page, another paper, then we cannot use an on-page connector. This is our exit point of the flowchart subsection, and this is the entry point of the flowchart subsection. After we input the first integer, we input the second integer. And after we input the second integer y, we now proceed to computing the sum of x and y. Computing the sum of x and y, it's a process, so we use either a rectangle or a square. So in our case, we'll use rectangle, so we could write longer labels here. So we would say z is equal to x plus y. You could use mathematical expression, or you could use statements like compute or add x and y and store the result to variable z. You could choose to write the label that way instead of writing a mathematical expression like this one. But most people find this mathematical expression easier rather than writing a whole long statement. The next process is to output. So since there is no more space, we could have another on-page connector and we label it B, okay, so that it would be different from A. Usually, the labels of the connectors are uppercase letters or capital letters or big letters starting with A, B, C, and so on. That is the standard or normal convention for labeling the connectors. So this is again an exit point on-page connector of the flowchart subsection, and this is the entry point of B, okay, on-page connector. So after we compute for the sum z, we will output that value. Since it is output, we are going to use the parallelogram symbol, and we could say here output, or you could use the word display, output the sum z. We then end the flowcharts. The last symbol is called off-page connector. This is a connector symbol just like the on-page. The off-page is this symbol. It designates entry to or exit from one page when a flowchart requires more than one page. So for example, this is one paper and this is another paper. Say this is page 1 and this is page 2, one paper, another paper. Then after this computing the sum, this would be the next, right? So since this is another page, you continue the flowchart on another page or another paper or another board, then you cannot use an on-page connector. Instead, you're going to use an off-page. So we use an off-page, so it would be like this. So we call this now an off-page connector. This is the exit point of the off-page connector, and this is the entry point of the off-page connector. This time, let's discuss the flowchart symbol diamond that allows us to make choices in our flowchart. Now we call this construct a selection or if then else statement, and it's a choice provided between two alternatives. Last time I discussed the diamond flowchart symbol, which is the decision symbol. Recall that the diamond symbol or the decision symbol has one input flow line and it has two output flow lines. So say we have the first output flow line here and the second output flow line here. What we have here is a question that is answerable by a yes or no, or true or false. So maybe you would say here yes, no, or you could use true, false. And so for example, if we have a problem to input an integer and identify if it is less than or equal to 10 or greater than 10. If that is the problem, then our algorithm first input integer x. Second is, now that we have x, we would be saying if x is less than or equal to 10, then output or display the statement x is less than or equal to 10. You continue with else. So you say else, output or display the statement x is greater than 10. And then that's the end, right? So if we're going to draw or construct the flowchart equivalent to this algorithm, you start and then we initialize variable x. We set x to 0. After that, we input the actual value. After the input, we have the diamond or the decision. This is x less than or equal to 10. That is the symbol in mathematics, less than or equal. Or you could use the symbol for less than or equal in C programming language, which is less than or equal. Okay, so that is the less than or equal symbol. Left angle, and then after that, adjacent to it is the equal. Okay, there is no space in between. You cannot write it this way, then a space and then equal. Okay, you cannot separate the two symbols by one space. It should be written like this. There is a question mark here because we are asking if x is less than or equal to 0. If it is yes or true, we could use the label true or yes. Another output flow line is the false. That is when x is greater than 10. So if it is true, then output this statement. So since this is output, we will use the parallelogram symbol. Okay, so we say output the statement x is less than or equal to 10. And then if it is false, we would output x is greater than 10. Another parallelogram, we would say output the statement x is greater than 10. So whichever of these two output flow lines will occur, the program will exit, right? So either this way or this way, your program will exit. So we have here the end. So this is now our flowchart equivalent to the algorithm. Okay, so we will just review the arithmetic operators as well as the relational operators. So you know this already to be addition and this one as subtraction. And we use asterisk for multiplication and the forward slash for division. For the relational operators, we use this one for equality. And take note that these two symbols are adjacent. There is no space in between. And this is for greater than. And this one for greater than or equal. And for less than or equal, and not equal. So for operators having two symbols, take note that there is no space in between. The third group of operators is the logical operators. This is the symbol for the not, the symbol for the and the symbol for or operator. Now again, just like relational operators, for logical operators and or, it consists of two symbols, and again, there is no space in between. For the precedence rule of the operators, what is precedence rule? This is the rule that tells us the priority of the operators, which is performed first, second, third, and so on. Now, the first priority are the arithmetic operators, the addition, subtraction, multiplication, and division. The second priority is the group of relational operators, which are this. And the third priority is the group of logical operators. For this group, arithmetic operators, the precedence rule among these four is, from mathematics we learned it is MDAS, right? Meaning multiplication, division, addition, subtraction. But in programming, the precedence rule is, first priority is the multiplication and division. The second priority are the addition and subtraction. Meaning you are going to perform all the multiplication and division first, and then you're going to perform all the addition and subtraction. But it doesn't mean here that multiplication should be performed first before division, or addition should be performed first before subtraction. Multiplication and division have the same or equal priority. And the one that will be performed first is whichever comes from the left going right. Okay? And also this one, whichever comes from left going to right. For example, we have A plus B divided by C minus D times E. We have here the four arithmetic operators. So first, you are going to perform all multiplication and division. So this would be first. Okay? Evaluate this one or perform division. So this is first, evaluated or performed. After that is this one. You perform multiplication. This is second. Okay? So since you have already performed all multiplication and division, then you scan again the expression from left to right and perform all the addition and subtraction, whichever comes first from left going right. So this would be next, the third operator to be performed. So the operands of addition are A and the value of this. After that, perform this. The left operand of this subtraction is the value of that. And the right operand is the value of that. But if we have something like this, A minus B times C plus D divided by E. So by this rule, multiplication and division first, left to right, this would be performed first. Okay, so this is first. And then after that, this would be second. Then after all the multiplication and division, then you go back to the left and perform all the addition and subtraction. So again, it doesn't mean that addition should be performed first. The rule again is left to right. So since from left going right, this is the first we encounter then this will be the next to be performed. So this will be the third operator to be performed. And the left operand of subtraction is A, and the right operand is this one. So we say A minus the value of this. And so this has a value now, the whole sub-expression. Then next we perform addition. Okay, so this is the fourth or the last to be performed. And for addition, the left operand is this value 1 here, and the right operand is this value 2 here. Now, among relational operators, they have equal priority, and we perform in the order of the operators occurrence from left to right. And the third is logical operators. For logical operators, this is the first priority, and this is the second, and this is the third. So say for example, we have, okay, so say if this is our whole expression, so which are we going to perform first, second, third, and fourth, and so on. Now we have logical operators or, and the not. So since we have here parentheses, we are to evaluate what's inside the parentheses first. Okay, so inside this parentheses, we have addition and equality. So since this is arithmetic operator, we perform that one first. We add x and y, and the value of that, we check if it is equal to z. Say for example, the value of this is false. In here, we have one sub-expression and second sub-expression, or the center sub-expression, and this is the third, which is equal to false. So for the first sub-expression, we have relational operators, so we perform the arithmetic operators first. So starting with the left, this is x plus y, so this has a value now. You add x and a, the value is val 1, and then say this part here is y divided by b minus e, so we perform this one first because this is division. Perform first division before the subtraction. So say this is value 2, we divide y by b, and then the value of that, we subtract e. And then we have now for the whole sub-expression here, value 2. Then we check val 1 greater val 2. Say for example, this is false. And then the center or middle sub-expression, this is the relational operator. So we perform first the arithmetic operators. Starting with the left, we have minus, divide, plus. So we perform this one first. So this has a value. Next to perform is this one. So a minus val. Okay, so say we call this val 1 plus e. Okay, so val 1 plus e. Say for example, this is val 2, and we have val 2, this one, val 2 less than or equal the value of that. Okay, and in this sub-expression, we have minus and plus. So left side first, x minus a, we have val 1, and plus b, say for example, this is val 3. So to perform less than or equal operator, we have val 2 less than or equal val 3. Okay, say for example, this whole sub-expression here in the middle is true. So now we have false, which is this one, or, and then the middle sub-expression is true. And then we have the and then after the end, this sub-expression is equal to false. So this is now the partial result. We are left with or and operators. So which of these two are we going to perform first? According to this, the second priority is this one, and this is third. Therefore, we get this one first. So true and false, that would give you false. So false or false is, the final answer is false. Now, let's try to review the truth table of the logical operators. Say, for example, this is operand x and operand y. We have here not x, not y. Then we have x and y. Then we have here x or y. If we are going to consider all combinations of the values, there will be 4, right? So say this is false, 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 true, true, false, true, and true. So not x, you are going to reverse this. So not x of that is true, not x is true, not x is false, not x is false, not y. This is false, so this is true. True becomes false, and false becomes true, and true becomes false. For the x and y, the AND will return true if both operands are true. If there is at least one that is false, then the result is false. Okay? So false and false is false. False and true is false. True and false is false. And true is true. So again, the AND operator, if at least one operand, either x or y or both, are false, then the result is false. The only time that the AND operator returns true is when all the operands are true. For the OR, what is the rule of OR? It is when at least one operand, either x or y, is true, the result is true. So false or false is false because there is no true value in any one of this. False or true is true. True or false is true. True or true is true. So again, when at least for the OR operator, when at least one operand is true, like this, or both, then the result is true. The only time the OR operator returns false is when all the operands are false. Let's try to do this given example. The problem is construct a flowchart that will convert an input number in Fahrenheit to its equivalent measure in Celsius, and then write its equivalent algorithm. Or we could start with writing the algorithm, and then after that, we construct the flowchart. Say we write here the algorithm. First step is what? Input the temperature in Fahrenheit. Okay, you could call it F. What's next after we have Fahrenheit F? We're going to use the formula. What is the formula for converting Fahrenheit to Celsius? Say we use variable C for Celsius. We say C gets 5 divided by 9 times Fahrenheit minus 32, right? That's the formula. So the input Fahrenheit minus 32 and then 5 divided by 9 times that, that is your Celsius equivalent of the given input Fahrenheit F. And then the third is to output the Celsius. Okay? So we say output the equivalent temperature in Celsius C. So that is our algorithm, right? Is this working? Yes, we input the Fahrenheit because it says here, we'll convert an input number in Fahrenheit, okay, and it will output the Celsius, of course, okay, the one that we are going to calculate. So how about for the flowchart? We start with this symbol, okay, the terminal symbol, we label it with start. and then a flow line. You could initialize the variables we use. What are the variables we use? F to 0 0.0 and C to 0 0.0. Now, why is that we initialize it this way, not just 0, but 0 0.0? Because we are trying to tell the reader of this flowchart that Fahrenheit and Celsius are real numbers and not integers. So we include the 0.0. So we could add here a comment: F and C are real numbers. And then after we initialize, the first thing we do is we input. So parallelogram for input symbol, we say input temperature in Fahrenheit, and we call that F. After we input, this is a process, so we use a rectangle symbol, and we say C is computed this way: 5 divided by 9 times F minus 32. And then after the process, we have the value of F already. Then we output using a parallelogram. We output the equivalent temperature in Celsius, and we call that C. After that is the end. We have here the terminal symbol to end the flowchart. So this is our algorithm, and this is our flowchart for this given problem.